just getting into Python, here are 10 Python libraries you absolutely need to know and how to tell when to install each one. First is NumPy, and as the name suggests, NumPy lets you work with numbers in your code. It gives you fast, compact arrays and a huge set of math tools so you can replace those slow Python loops with quick NumPy operations that immediately apply to the entire array. You'll use it for basic linear algebra, heavy number work, and just any task in general where you're applying the same math operation to many values at once. Some of the most common NumPy operations include numpy.array, which quickly turns a Python list into a numeric array, numpy.arrange, which creates a range of evenly spaced values, and numpy.mean, which calculates the average of the numbers in an array. Next is the pandas library, and this has everything to do with your data. Essentially, it lets you work with rows and columns exactly like you would in a spreadsheet. You'll use it to read CSV files, clean messy data, join tables together, and summarize your results. Next, matplotlib is a library that helps you turn numbers into charts. You'll use it to make line plots, scatter plots, bar charts, histograms, and more to interpret or present your code. Now, Seaborn is a library that builds on matplotlib to make nicer, clearer charts with less code. You'll use it for heat maps, box plots, and any other statistics-friendly visuals that just look good by default. It's really handy when you want to gain a lot of insight from a visual without spending time on style settings, and that's why Seaborn is usually the choice library over matplotlib for exploratory data analysis, which is an approach to summarizing the main characteristics of a dataset. Now, as a machine learning enthusiast myself, this next library has to be one of my favorites. Scikit-learn gives you every classic machine learning tool that you could possibly want in a clean package. You'll use it for regression, classification, clustering, scaling, and model evaluation, and it's the right pick when you want a good first machine learning model without getting into deep learning. But if you do want to get into the sphere of deep learning, you'll want to look into PyTorch. PyTorch lets you build and train neural networks with very flexible code, and it can use a GPU to make the training much faster. You'll use it to deal with images, text, and audio, or wherever you're stacking layers, tracking gradients automatically, or even updating weights with optimizers. It gives you tensors for fast number work and those simple Python classes to define models with lots of layers that run on the CPU or GPU. Use PyTorch when the simple scikit-learn model isn't enough, when you plan to squeeze every drop of performance out of your model, and when you plan to use a GPU. A few names you'll see often are torch.tensor, which holds the numbers in an array, and dataloader, which loads the data to your model in small batches. Now that you've seen what PyTorch offers, it helps to place it next to TensorFlow and see how they compare. PyTorch feels very Python native, with eager execution by default, simple debugging, and tight control over the training loop. This is why researchers and people building custom layers tend to love it. Now, TensorFlow, especially with Keras in TensorFlow 2, also runs eagerly by default, but it adds easy ways to compile parts of your code into faster graphs. PyTorch makes it easy to experiment and iterate quickly, while TensorFlow leans into a larger production ecosystem with polished tools for serving the models, building input pipelines, and deploying to phones and browsers with TensorFlow Lite. But many teams start in PyTorch for a baseline exploration and then cater to the model's needs. Next, let's talk about requests. You can use the request library when your code needs to talk to an external website or web API in a simple, sustainable way. You can get data from a URL like downloading a page, post JSON to send information, and set headers for things like API keys, while also choosing timeouts so your program doesn't hang forever. Next, let's get into CatBoost. CatBoost is a gradient boosting library that works great on many tables of data, especially when it's categorical data because it handles them without one-hot encoding. You can use CatBoost when you want very strong accuracy right from the start and you like to avoid heavy feature engineering for your categories. Essentially, it's a great way to get a high-quality model without too much prep work. And last but certainly not least is PyTest. PyTest is like the safety net for your code. It lets you write small, clear tests that let you check if your program still works after you've changed it. Now remember that you don't need every single library from day one. Start with the basics and add tools when you actually need them. As you grow, the language of libraries will become native to you. But for now, save this video to come back to whenever you're in a rut for libraries and follow for more.